Okay. Sorry, I'm going back. All right, so remember, if it's two non-polar molecules, they'll do London dispersion. If it's a non-polar and a polar, they'll do London dispersion. When in doubt, everything does London dispersion, okay? Okay, last one. Letter C on this one. Water, polar, non-polar, you guys?
Not polar.
It's polar. Remember, water looks like this, where it's got the two lone electrons. Lone electrons mean polar. Okay. NaCl, would you say it behaves more polar or more non-polar? This one behaves more polar. It's actually ionic, but it has these partial, it's got these positive negatives. So this one, is it going to do London dispersion?
Yes.
Yes, because everything does London dispersion, but it's also going to do something else. What else is it going to do?
Dipole.
It's also going to do dipole. Okay, it's going to do both. Okay. Let's go to the next ones, D, E, and F. So looking at D, this is, oh no, what's happening? Okay. What do you guys say? Polar, non-polar for D? It's going to be polar, good. What about for H2O? Polar, non-polar? Polar. No, it's polar. Okay. So is it going to do London dispersion? Yes. London dispersion, is it going to do dipole? Yes. Now we need to figure out, is it going to do hydrogen bonding? To do that, I like to draw a Lewis structure. And try not to talk and write at the same time. So our Lewis structure looks like this. Okay, what do we think? Can this thing do hydrogen bonding? Yes, it can. The hydrogen bond's going to happen right here. So this one will also do hydrogen bonding. Okay, letter E. MgCl2. More polar, more non-polar. What do you guys say?
Polar.
It's going to be more polar. This one's actually technically ionic. So if it's ionic, it's going to behave more polar, right? Because ionic has charges. Okay. So if they're both polar, are they going to do London dispersion? Yes, go ahead and write London dispersion. Are they going to do dipole? Yes. Will they do hydrogen bonding?
No.
No, they do not have the required elements for hydrogen bonding. Last one, NH3. Remember our Lewis structure, NH3 looks like this. Polar, non-polar, what do you guys say?
Polar.
It's going to be polar, right? The lone pair of electrons. We got two polar molecules. So this one will do London dispersion. Because everything does London dispersion. Because they're both polar, it will do dipole. And it will also do hydrogen bonding because it has the required elements. So this one will do hydrogen bonding. All three. Questions on the bottom of page 5? Anything on page 5? Okay, last thing, and then I'll let you guys loose. So here's what you need to do. Go to page 9 and locate numbers 1 through 5. Okay, guys. So for these ones, you're doing the same thing we just did. There may be 1, there may be 2, there may be 3 answers for each question. Okay, so the 3 choices, remember, are listed up here. Okay, so what's going to happen is you'll just answer questions 1 through 5. When you bring it up to me, I'll check it off. Once you have it checked off and you have returned your colored pencils, and if there's any other garbage around, you want to pick that up, that'd be awesome. Okay, then you guys can go. All right. So help each other out. You gotta get it checked off by me, which means it has to be correct. So bring up page 9 once you are ready.